Welcome to Vibotech. As always, my name is Nick. Today is going to be a project update. I announced a few projects, well, two projects, sorry, a while ago now. Don't know how many weeks now. University. I'll link them in that side of the screen for you guys who want to have a look at that, what we're talking about today. So this is a bit of an update about those projects, where I'm at right now with them, and what's happening with everything else. So first project up is the Nixie Tube timepiece. Is now not a timepiece. Due to one of my comments of one of my really great teachers at lecturers at university, he basically just said to me, with your skills and and I know your knowledge base, and a clock or a timepiece is too simple. So the Nixie Tube timepiece is now getting turned into a Nixie Tube display 6.5 digit digital multimeter, which will be pretty cool. So on that note, yeah, the Nixie Tube is now, or Nixie Tube timepiece is now a digital multimeter. So similar to something like this little guy, but it will be benchtop and 6.5 digits. So that's pretty much the reason. Now, more people may ask, why 6.5 digits? 6.5 digits is basically around, well, how many of these Nixie Tubes do I actually have that work? So, yes, I now have my Nixie Tubes. They're here. From that, what also came out was the sockets. So I actually have the sockets for the PCB. As well as from that as well, I've built myself my testing system. So also the other board, the other piece I was waiting on, which was the test supply, as I refer to it as, this little PCB up here, which you guys are not going to be able to see because this thing doesn't autofocus. That's sitting here as well. So that's basically what this board is. It's a character testing plate. So I can stick a Nixie Tube in here that fits this socket, hit the buttons. It runs off a 12-volt battery, so it's pretty simple to use, and it allows me to test Nixie Tubes fairly quickly, not so automated, but fairly quickly enough that I can see which ones are good. From that, testing the 8 Nixie Tubes I've got, that gives me 7 of these guys that work perfectly, 100%. That's where the 6.5 digits come from. For a 6.5 digit meter, you need 7 display elements, I suppose, or 7 display digits. Or as far as I can find with that. So that's where that comes from. I would have liked 7.5 digits so I can use 8 of these guys, but not enough Nixie Tubes to do that. I don't have time or money to go get enough of them. Although I will have to order some special Nixie Tubes for the characters. I may link something again. I don't know. Yeah, no, I can link. I can link in the page to the specialized tubes I'll need that contain the like micro, milli, mega, giga, killer. Those sorts of ones, so the units, the SI unit denominations, as well as the unit characters, so stuff like so farads, henries, amps, ohms, volts, that sort of stuff. Also, I'll need another special tube that does positive, negative, and AC symbol, so I'll need that as well. That's 3 tubes I'm going to have to find, which may be difficult, but that's okay, I'll find them. Where am I up to? Oh, okay, I'm up to... Yeah, I actually have to write myself notes so I actually remember what I'm talking about, so I can keep this short. On that note, though, DMM, digital multimeter. Of course, I'm going to have to make stuff that turns something into a voltage range that I can actually use inside an analog to digital converter, much like what you'd see in, let's say, an Arduino, or in this case, it's going to be a bit more punchy than an Arduino. So, on that note, I have 2 DC amp meters working, because DC current is stupidly simple to measure, so I thought I'd get those out of the way and done. Right now, I have a 2 amp and a 20 amp rail, or range, I suppose, working perfectly. Like, perfectly. Though their lower limit, I think I have written, yeah, their lower limit is 100 microamps on a 2 amp rail. I was hoping to have a 1 microamp full scale thing, or full scale range. That means I'll probably have to make a third one of these guys with a much bigger burden, or much bigger current sense resistor. I will be doing a sort of a how to measure X series, I think, at this stage, of how do you go about measuring DC current, DC voltage, AC voltage, stuff like how do you measure ohms, how do you measure inductance and capacitance, and then sort of bring all this back together and looking at the multimeter project as a whole. So that's that. I also have a somewhat working AC current measurement system that is true RMS, but for some reason it doesn't like going below an amp, so I'm just going to have to work on that one. So I've got a current sense transformer. You run the wire through it, measures AC current, all good and dandy. But for some reason, it doesn't like going below 1 amp. But I gotta work that out. I think there's something to do with my burden resistance. But again, we'll probably cover that in how do you measure AC current series, or how do you measure stuff. Where am I up to? Oh, that high current AC current range is limited to 20 amps. I'm trying to have things up to 20 of something, if that makes, or 2 something. So 20 amps DC, 20 amps AC, hopefully 2000 volts AC and 2000 volts DC. I'm hoping to have a 2 gig ohm range on the multimeter as well. And I'm hoping to be able to do a 2 farad and 2 Henry range as well. That's the hope, if I can do it. If I can work out the math for that. But that's the idea behind that. Most people say, well, how the heck are you going to power all this? This kind of links back to the other project that I mentioned, which was the power supply project. From that, I'm working out the fact that I just right now don't know enough to make a very, very low noise supply. Because in a multimeter, your voltage rails are effectively your reference for your op amps and a lot of other stuff that's on there. You need a really, really, really low noise system, or low noise power supply. Why is my English not working today? Anyway, so really, really low noise. So we're talking microamps peak to peak here, or no, microvolts peak to peak noise. You're not going to get that from a switch mode power supply. So I am having to go linear. I've already sort of worked out most of this already. When we mean most, I mean pretty much all of it. There'll be a plus or minus 12 volt analog rails. There will be a positive 5 volt rail for digital stuff, and there'll also be the 200 volt rail for the nixie tubes, which will all come from the one system. At this stage, the digital rail can be switch mode. Particularly the nixie tube rail can be switch mode as well. It just needs to be heavily regulated, so we don't have nixie tubes can deal with about a volt peak to peak, but of course I want to keep it under that to make sure that I keep the longevity of these tubes, because the less ripple you have, the longer these nixie tubes last. That's pretty much the way it works. Also, if you run a nixie tube at a slightly higher voltage and less current, it's like running a light globe, like an incandescent light globe. You run an incandescent light globe at a fairly high voltage and a fairly low current, it lasts forever. So yeah, it's like any valve or any evacuated tube. That's pretty much that. Okay, I think that's all the project update to do with the now nixie tube digital multimeter that I'm now making. So on to the second project, the power supply project. Nothing has really changed with that. It's still going to be plus or minus 10 volts. It's still going to be up to 3 amps on both rails. There'll be isolated rails. There will be completely separate adjustable current and voltage rails. I have a block diagram of that already hand-drawn, I suppose, or digitally hand-drawn, of what goes where and what I need to work out, what I need to learn about that sort of stuff. So stuff like, okay, I need to make a switching circuit. How am I going to make that switching circuit? What's going to control that switching circuit? Am I making it flyback versus a flyback system versus a self-sensing system? How do I keep that isolation, but still have that feedback network that is required to measure the output current of both rails to know that this system is going to provide the right frequencies, the right switching frequencies, therefore the transformer works. And at this stage, I'm actually looking at pretty much building my own toroidal transformer. Because it's such an unusual project in general, this is something I do actually have down in my notes, the transformer has been one of the hardest things to try to source. Because it's basically a one-to-one transformer, and it's meant for higher frequencies, and I want it to be high efficiency, and it needs to meet standards, and this and that, and it needs to meet isolation standards. There's so much that it has to do that I've put feelers out to transformer manufacturers before people wondering why don't you just call up a custom transformer joint. I have done that. They've got back to me with quotes ranging from $1,000 to $3,000 for a one-off transformer. I wasn't planning to spend any more than about $400 on the whole bloody project. So that's an issue. Because again, it needs to be high efficiency, which means you're talking a very expensive core to start with. We're talking fairly high currents on the primary side. We're talking up to 6 amps on a 12 volt rail, or probably about 7.2 at this stage, I think is the calculated amount, although I probably rate it to about 10. On the primary side, we're talking 3 amps or probably 5 amps rated on both secondaries, and there's 2 secondaries, and they're isolated secondaries, not tied secondaries or center tap secondaries. So again, it's a bit of a wild card when it comes to transformers. I've already looked on DigiKey, Mauser, and there was another one. Anyway, if I remember what the hell it's called, I'll put it here. But I've already looked on 3 fairly big websites to do with Element 14. Thank you, Brain. Element 14 was the other place I looked for transformers. And nothing really met the specification. A lot of transformers you'll find, be it switching or linear, are all really rated for the mains voltage. Now, the real purpose behind this project was to have a portable adjustable power supply, one that you don't necessarily need a mains outlet for. You could plug it into, let's say, a car battery and it would work. That's the real essence behind this project, is not necessarily to have it mains powered or have it always tied to a benchtop power supply or an industrial power supply, but to be portable. Therefore, you can take it, let's say you run an electronics business out of the back of your car, or ute here in Australia, pick up if you're in North America. You don't really have that ability to have a high efficiency adjustable power supply unless you want to run an inverter, a 240 volt inverter, and then run some form of adjustable benchtop power supply. That being said, most of the adjustable power supplies are also single rail, not dual rail, and they're also fairly big. I wanted this to be fairly small. We're talking, I'm looking at a PCB design right now of about 160 millimeters long by about 70 millimeters wide. So we're talking, it's like 4 credit cards put next, like laid out on a table. So it's not huge, put it that way. And that would be boxed up in a nice aluminium box, so it's pretty strong and durable. That's the concept behind this at the moment. Actually, talking about PCBs, I want to roll back to the first project to talk about PCB design for that. Something I didn't put down in my notes. Right now, the idea I had for the PCB design for the multimeter was to basically have it to be modular. So each of the functions would be modular. So I'd have a 20 amp DC module, then a 2 amp DC module, then a 100 microamp DC module, and then I'd have the AC current module and the high and low current AC modules, and then I'd have the DC voltage module and AC voltage modules, this sort of stuff. So therefore, if you only needed that function, well, I could sell those boards in theory, make and sell those boards fairly easily. So therefore, those out there just looking for a high quality, high accuracy 20 amp DC current meter for, let's say, a solar project, or as I was saying before my camera cut out. Anyway, idea behind this modularity is so therefore if someone's doing a solar project or an RV project or some other form of mobile project that just needs one of these functions, they can go buy that one function that's a plus or minus 0.1% class instrument device. They can easily plug into an Arduino or their own homemade ADC device. Don't know if this stage if I'm selling, and I'm trying to work out how to build that ADC block at this moment. I'm not quite knowledgeable enough about analog to digital converters at this stage to know how big does my ground plane need to be? Do I need ground plane separation? If so, what's the separation distance that I require? How do I couple? How do I shield? How do I input to this? Do I need differential versus single-ended? A lot of my instruments are going to be single-ended, which is cool. Which means it's very easy and very simple for those who want to put this into things like Arduinos. It makes it so much easier. So the idea behind it was just basically plug-and-play modules that you'd put into this sort of base plate that clips into the overall design aspect of the thing. That means, yes, the digital side of things will also be plug-and-play, I suppose. That at this stage will be a single board construction. So I had an idea, I don't know if people are up for this, but the FPGA I'm planning to use in this digital multimeter is about $130 by itself, bare chip, on DigiKey. It's a bit of a beast, but the reason why I'm going for that FPGA, if people are wondering when you actually may want to look it up, It is a it's Xilinx Vertex 7. Let's see if I can remember the product number off the top of my head. XC7K70T, I think. Don't quote me on that one. I'll put it here. How does that sound? If I can remember it. If I can remember to put it in, I'll put it here. It's a bit of a brute. It has 384 I/O pins. It's pretty much the highest I wanted to go without going stupidly crazy and spending $5,000 on an FPGA. It has more than enough gates or more than enough logic elements to do everything I need to do in it. It has enough mathematics, operators, and systems inside of it to do pretty much anything I need to do with it, literally. I was planning to have USB output and stuff like that, but I was planning to basically build it up as sort of a little plug-in board, similar to something like the Pablo. But the problem I have with a lot of these FPGA plug-in boards is the number of I/O pins. If you're trying to interface 10 of these suckers to one of these, you're going to need 130 I/O pins. Minimum 130. At an absolute minimum, you're going to need 130. This includes the anode switching if you wanted to do anything like that. In our case, it's looking like 140 at realistic, like very low level realism. I'm talking 140 I/O pins to come out of this to go to those. Or something a few stages up from this. And there's no real sort of plug and play FPGA that's like that I've found. So basically I'm going to release, I hope to, release something like that. And that's one reason why I'm calling it the Freedom FPGA, is because it allows anyone to do whatever the hell they want with it, basically. So yeah, 300 odd I/O pins, pre-done wiring with power, so you just plug 5 volts power in, it has USB on it, has a good quality SPI flash chip on it, so you can store a shite ton of program on it, and a shite ton of variables on it already, and it just allows you to do whatever you want to do with it. And that's really the idea. You're not locked down to, I must use this memory, or I must use these I/O pins, or I have to fill this board chip, this sort of board layout if I want to make a shield or a plug-in board for it. So that's the real concept behind this at the moment. One big ass board that's going to be basically split into 3 sections. You'll have your high voltage that will go up to the panel, your digital in the center, and then a whole bunch of analog modules that will interface to an ADC, analog to digital converter that is. And the power supply is playing basically up the back. I am planning to make this one mains supplied, just because linear power supply, you're going to need 240 volts. I can't really do much about that. Most people ask, well, am I making this open source? The answer is yes. I do plan to make these open source because sharing is caring. But if you do use it in your project, give credit, it's all good. I don't exactly have a medium for this at the moment, for sharing stuff out. At this stage, I'm looking for something like maybe I just share them on the EV blog or something along those lines, just to get them out there, get people's thoughts on them. But at this stage, that's an update about the 2 projects, the power supply and the now Nixie tube display based 6.5 digit digital multimeter. So without further ado, I'm Nick from Fibo Tech, and thank you for watching.